Hello, everyone. Welcome to today's webinar, our first of our industry series here to kick off 2026 on RoadEng applications for mining. If you haven't joined a webinar of ours before, my name's Erin. I'm the operations director here at Softtree, and with me is our resident webinar presenter / training guru, Matt. So today, really, an action-packed 45 minutes. I feel like we are going to be going longer, but it is worth mentioning that this is, part one of a 4-part series that we're going to be doing to start the year. So over the next 7 weeks, we are going to be tackling mining, forestry, county engineering, and renewables. And in each of these different industries, we're going to be focusing on, obviously, very specific examples that are applicable to them, but also on the different tools inside of RoadEng that really can help you. And in particular, the new tools that are coming in version 12. So today, we're going to be focused on, I'm going to say 3 core examples, and then of course, time permitting, an extra one on stockpiles. But we're going to start the webinar discussing sort of more in terms of exploration programs and potentially for quick and easy access road design. Head into a little bit more depth into a pit design, and then sort of finishing with our most of the complicated of the 3, which is a haul road design, sort of 2 parts to that. The main haul road out of the pit, and then actually taking a ramp and part of the haul road into the pit. So we're going to be tackling those, and then of course, if we're not too horribly over time, we're also going to jump and do a stockpile volume calculation as well. It is worth noting, today we're using version 12, and this is our upcoming release. It's currently out in its 2nd phase of beta, and today we're going to be showing you sort of 3 key tools that are coming in that release amongst the myriad of awesomeness that's in it. First and foremost, we'll be talking about the buffer benching tool, whose name still could change pending release. But yes, the buffer benching tool that we've got. We're going to be including a new Berm template, that once we get into that haul road side of things. And then lastly, we're going to give you a sneak peek at the brand new hot off the press 3D viewpoints functionalities. This includes being able to have your 3D view inside your output sheets, and being able to have multiple different 3D views that you can quickly navigate and jump between, and we call those viewpoints. So some exciting stuff coming. Yeah. So bit of housekeeping, I should say, before we officially get things started. If you are new to RoadEng, pretty important concept. We are a modular software, and what that means is we aren't just one program. We actually operate as sort of 2 mini programs. The first is our terrain module, and this is where we do sort of our more typical site design side of things. This could be, your pit is going to be done there, your stockpile, the nonlinear infrastructure design. This is also the place where we handle all of our survey data import, as well as the building of our terrain models. And then we have a special optimization tool that exists inside of terrain, and that's called Path Explorer AI, and we're going to include that today. And then we have our location module. And this is where we do all of the linear infrastructure, whether that's roads, ramps, conveyor design, channel design, all of that is really, really well suited for that sort of very specific linear infrastructure setup that the location module is based on. It also has a special tool for vertical optimization, where we optimize the earthworks of an alignment, and we'll take a look at that as well. Okay, my other quick note before we get into that first project type, just a bit more information on those 2 different types of optimization. So as I mentioned, inside of terrain is Path Explorer AI, and these are both add-ons to core RoadEng. So we like to obviously make a differentiation. They don't come standard in the regular one. This is in the RoadEng with optimal version. Path Explorer really solves that landscape level problem of where do you put a road, and we're going to see this used in both the haul road as well as that sort of exploration phase where we're making a basic access road. It reviews hundreds of millions of options in a couple minutes, and so we apologize. There's going to be maybe a minute and a half of solve time that we're going to have to live with in this webinar today. And then the second optimization tool, as I mentioned, really it is that detailed profile optimization based on specific cross sections, ground types, and gets you sort of individual material costs, considers all of that in a very, very large and complicated problem, and is able to help you fine tune that profile to really minimize cost. Okay. Our first project type. We're going to start with access roads. Here, key steps, import that survey data, build our terrain model, head over and use Path Explorer AI, again, within the terrain module, and then we're going to quickly show you what that process looks like to take it from Path Explorer into a full 3D geometric design in hopefully less than 4 minutes. So with that, I am going to pass the screen to my colleague, Matt, and we'll get going on our first project.
All right, so as promised, we're going to start from scratch here. We're going to pop open terrain. We're going to click insert, and I'm going to just start by bringing in my DEM data. So I'm going to use this for my topo surface. We could work with the raw LAS files very easily as well, or conventional survey data if we had it. But yeah, in this case, we're running with DEM. So we'll hit OK. So that's being brought in. I'm not going to wait for that to draw. If we'd like, we can add in an ortho image. So in this case, I'm going to just right click. We're going to add that in as a background. And I happen to have one here. And there we are. And for this particular project that we're dealing with, well, or any project, when we bring in our topo data, that's going to be points and lines. And to turn it into a surface, we're going to come up here, we're going to click terrain modeling, click generate, and I'll skip creating contours at the same time here, but we'll create a tin surface for our project area. So it's going to take a moment as it thinks. And we'll have a peek at that in the 3D view here as well. So that's our project extents. And for this particular project, well, being we're looking at exploration access at this phase, well, we probably want to consider where the streams are on our project. So I'm going to run the hydrology tools. So this is going to, as we use that generative Path Explorer tool, we want to take into account that the streams cost more than, well, just the earthworks at that location. So we have our streams generated, and we could draw in where we'd like our start point and end point to be. But in this case, I happen to know it. So I have another file here. I've got a start point and an end point in here, and I'll make this a little easier for folks to see. So if I want to go from here down to here, and I don't want to take the time to click around and figure out where I should go manually and also find a less good solution, I'm going to come over to the optimization tab. I'm going to click Path Explorer. So I'm going to tell the software I want to go from this point to this point. This being an exploration road, we're going to go relatively steep. We'll go up to 15%. I'm going to let the curves be quite tight. So minimum radius of 15. And we are going to, well, add in those stream crossing costs. So we'll come over here. I'm going to add a construction zone that's a polyline. And I'm going to say that each one of those streams, if we were to cross them, it's going to have a $5,000 cost associated with it. So we'll click OK. We'll let this run. And here's that part where instead it's going to take a minute or so to go from that point to that point, but it's going to give us 5 options to do so that minimize our costs.
Which is a great moment. I'm actually going to steal the screen back, Matt, here for a second. and talk a little bit more about what Path Explorer is doing, since I actually skipped that in my introduction, knowing that we had about a minute and a half for it to solve. So as you saw, Matt started off by defining a start and an endpoint. These are our two features, A and B. If you're a current user of RoadEng 11 and have Path Explorer, you're going to notice a slight change in what we're doing as we move to 12, and that is selecting just the endpoints as opposed to a feature. And that really is a gateway into some really exciting development that's coming with 12, which is full networks. So start with our A and B, we've got that tin surface. And then what Path Explorer is doing is it's dynamically searching that 3D space to find the most cost-effective alignments between those points. And of course, as you saw with Matt, he input a road width, he input his min-max grades, side slopes, our vertical offset, minimum horizontal curvature. And then we have the ability to add other geometric constraints. And really, these ones are quite exciting, and they really can help shape how Path Explorer behaves. Say, for example, you have an area that you certainly don't want an access road going through. Perhaps that is a sensitive habitat. Perhaps it's some existing infrastructure. You can delineate that with a no-go polygon, and that's going to tell Path Explorer it can't go through that. Similarly, you can delineate different polylines as no-go polylines. So Path Explorer cannot cross them. Again, a lot of times we see this being used for, say, sensitive fish-bearing streams or different habitats, or again, existing infrastructure, power lines, pipelines. You can delineate those as no-go polylines that you cannot cross. And then used most commonly, we see polygons and polylines of differing cost. So a polygon here could be an area that perhaps has a different type of ground type. Maybe it's more expensive construction. Maybe it's a swamp. You can delineate that and say it can go through it, but the cost is going to be substantially more. Or in the case of polylines, you're crossing a stream. There's going to be the likely need to bring in a culvert or perhaps a bridge, and you can start to delineate those with different cost. And this really helps shape and influence how Path Explorer behaves. So with that, I am going to pass it back to Matt, and hopefully that little introduction helped to give a little bit of context about what Path Explorer is doing here behind the scenes.
All right, so it's done running. Switches to this, we can see that it's found our 5 options. And there we are. Now, for these 5 options, if I wanted to see which one's cheaper than the others, I can come up here, I can select that. And well, that's our cheapest option that's highlighted magenta. So we're going to take that over, and instead of just having this really smart line on the map, we're going to take it over to the location and get a really quick actual geometric design for what we're working with. So I'm going to hit save here. I'm just going to save this as topo. And it's a reasonably large file, so it's just taking a moment here to save. And we'll switch over to location, so the other module. So in location, I'm going to create a new location file that references that topo file, which we've just saved. I'm going to use that Path Explorer solution as my initial alignment. And we are going to make a couple tweaks, and we'll talk about more of the actual clicks that I'm doing when we get to our haul road example. So there's going to be some overlap between the 2 workflows. I'm going to apply my cross-section template that I'd like to use. And I'm going to run polyline to alignment. And now we've got this proper alignment with curves and tangents, and then I'm going to do my vertical optimization to minimize my earthworks while adhering to my design constraints. So I'm going to just add one control point at the start, and then we'll hit this. And it's going to another process that's solving a really big problem, but it's doing it really quickly. And while the software is going to take those design constraints that we have, so our max grades of 15%, we're accounting for vertical curves, and then we're also accounting for our earthworks costs and the material movement costs. We'll let this go. And there we are. We've got our proper vertical alignment visible in our profile. We can see we're ramping down to get to that desired exploration site. We can see we've got our volumes being tabulated here. I can see my cross-section geometry. I can see that plan view as well. And there's some more nuances, but I'll pass it back to Erin before we look at this again.
Perfect. Okay, so we are going to head into our second project type as we kind of build the foundation for how RoadEng can be used in different mining scenarios. So now that we have had our access road to our exploration area, perhaps that is suitable for a mine site. And here we're going to now show you how we can go and do a pit design. So similar steps to start off pretty much every project in RoadEng, which is importing your survey data, building that terrain model. And in this case, we're going to just continue working within the same project. So that step is already done for us. So here, inside a new instance of terrain, we're going to define the pit shape, and then we're going to reference our topo surface in the background. Then we're going to leverage the benching and buffer tool and a couple other tools in order to help get our pit shape. And then if we wanted to, we could calculate volumes. And now we can include this in our model as we continue working forward. So second project to show you how to do it in RoadEng for mining applications, we're going to go take a look at pit design and specifically calling out that new benching buffer tool that's coming with version 12. With that, we're going to make Matt the presenter again.
Alrighty, so yeah, using that same file, and I'm just going to hide a couple of those features that we used when we were in Path Explorer, but the context being, well, we want to have a pit at that spot that we've previously ran Path Explorer to. So I still have my topo file. I'm going to minimize that instance of terrain, and I'm going to open another instance of terrain. So with this, if we're doing bulk earthworks like a pit, we're going to have our topo surface in one terrain file and the design in another. So in this other instance of terrain, I'm going to just add in that topo as a background. And there we are. And of course, we could come in here, we could draw where we'd like our pit to be. So just create a new feature. Or if we have, again, other features like to bring in and use those as a reference, we can. So in this case, I do have a shape that has my pit floor, target pit floor geometry set in it. So I'm going to just bring that in and we can see what we're dealing with. Sidebar, I haven't saved that terrain file where I hid those Path Explorer features. So if I hit save, it'll take a moment to save, but then they're dynamically connected. So that change is going to update in the others. So from this pit floor feature, if we want to do that buffer, we got our feature selected. We're going to right-click, modify buffer, and well, we can set our parameters. So in 12 here, we can see this is nice. Instead of having to know the direction our feature is drawn in, we can toggle back and forth and see, okay, if I buffer to the left, well, that's going outside of my feature. And since this is the floor, I would like that to be graded up from that feature. And I want that to be offset 7.5 meters. I want that slope to go up at 1:1. And then I want benching. So we're going to turn that checkbox on. And I want my benches to be at 0 slope, but I want them to be 5-meter offsets. And I'm going to allow this to go up to, let's say, 15, repeated 15 times. So we hit OK. And there we are. Now, with this, I'm going to go to my 3D view so we can see those benches. They're in 3D. I'm going to make it so I can see my topo surface. Let's make that. And I'm also going to make it. So right now we can see that. And if we want to have a surface for this pit that's extending up out of the ground from our pit floor elevation, we're going to create that surface for that feature. Oh, and with this, we do want those features to be modeled, of course. So we're going to click model. And in order to see that, well, we have our current surface. We're going to turn that on. I'm going to make it, we'll go olive just so it's a little easier to see. And there we are. So we aren't quite done yet. Obviously, if we were building a pit, we're not going to, well, continue building slopes up beyond where we're in cut. So here, how would I trim that surface down? Well, I'd go into calculate volumes. I'd tell it to calculate between our current surface and this other surface, so that background topo file. And I have this surface intersection calculation turned on. So we'll hit OK. And well, it's going to calculate our volumes. The other thing that it's going to do is going to calculate a feature that intersects that surface with all the other triangles here where we go through one surface to the other. And for that, since it's a really high resolution surface, it's going to take a little longer than instantaneous. So we can see it's running through, and we'll have that feature here momentarily.
I feel like this is a good opportunity to remind everyone you can ask questions at any time. There is a question section in your GoToWebinar panel, so feel free to open that up, type your questions in, and if you're watching this off of YouTube in the future, type them in the comment section below, and we are happy to tackle them.
Totally. And so we've got this feature, and I'm just going to change the symbol so it's a little easier to see. So we can see where we're going through the surface. And if we wanted to limit our surface to be within that, well, we can select that feature. We can click modify, break, add current feature. So we're going to break everything that intersects that line. And then we'll come in here and we'll select everything outside of it. So select feature by boundary. And we're going to hit delete. And then we're going to remodel that surface with this as a boundary feature. And there we are. We've got our hole with those benches stepping up at the progression that we'd like, with the 5-meter benches at 1:1, right up until we're out of the existing ground. And then we'd save that as our terrain file for our pit. So with that, I'll pass back to Erin.
Awesome. Somehow we are actually doing okay for time so far. So yeah, fingers crossed, everyone. Hopefully we're going to get through all 4 of the different workflows. So I'm just going to steal the screen back. and introduce our next workflow topic, which is a really fun one, which is now going into that more detailed haul road design side of things. So here we're going to start in that terrain module. We're going to leverage Path Explorer in particular for the part of our haul road that is out of the pit. So changing the design specifications to be more aligned with a haul road. Then we'll head over into location. We're going to define a template with a berm. And we'll show you a little bit about that as well. We're happy to make this template available in our template file format, which is called TPL. We can certainly share that with anyone who's interested in it following the webinar. From there, we're going to leverage some optimization tools before we get into the sort of more conventional and manual side of things as we design how that haul road comes down into the pit itself. So a pretty, exciting big piece. So I'm going to pass the screen back to Matt. We're going to go into that haul road side of things and continue building out this model. So Matt, as long as I find the right button, it's coming back to you.
Alrighty. So, kind of continuing along with that workflow, we've got our exploration trail down to figure out whether there's something viable there or not, and we've designed a pit. And then, well, we obviously are going to want access to connect that pit with other infrastructure. So again, just context back in the topo file. I'm going to add that pit now as a background here so we can reference one to the other or vice versa. So we can see we're there. And if we wanted to, well, that exploration road that we had coming down there, we're not going to use it once we're into mine operation side of things. It was quite steep. We want something gentler with broader curves and something that we can maintain our grade to access the pit floor. So I'm going to start by doing the kind of the out of pit portion of our haul road. And I'm going to say, well, I want to go from we'll say from start. I'm going to just draw it in rather than choosing anywhere else. And actually, just to make it a little easier to see too, I'm going to display it here. So I want my start point to be, say, right about there. And I want to have this go up and tie in with the existing road over here. So I'm going to draw another feature. I'm going to call this one end. And sure, let's tie it in right there. And then if there's anything else that we'd like to account for, we could. So in this case, I don't want to mess around with this, well, looks like a tailings dam or waste area. So I'm going to add in a no-go. So very similar to what we did with Path Explorer. The only thing that we've done extra here is we've added in that no-go Path Explorer when we did it for our exploration. So up here, we're going to change a couple things. One, we want to change the features that we're referencing to define our start and end. And two, well, I want to have gentler grades. So I'm going to knock this down to be 8%. I also want to have broader curves, and I won't go super broad here. It's still an industrial road. We want to be cognizant of kind of balancing speed with minimizing our earthworks. So I'm going to go 35-meter radius curves for our minimums. And then we're going to go to our construction zones. One, I'm going to just update this that, well, I still want to keep my grades at 8%, even at my crossings. And then two, I'm going to add in that other construction zone for my no-go polygon, which I've just created. All right. So very similar to what we did previously. We'll hit OK, and we can see though that based off having well, gentler design specs, so higher quality road, the solution is going to be a different location. And again, just like before, it's not going to be instantaneous, but it's relatively quick. And if we keep it here, we can see that as the calculation is solving, it'll tell us the status. So it's found some solutions. If we hit cancel now, it would give us those, but it hasn't narrowed in on whether it's found the best ones yet. So if we just wait, this will momentarily progress through to tell us that it's found the best 5 solutions given the information that we've given it. All right, and there we are. So we hit OK, and voila. So we've got our solutions. Now I'm going to, and I could have, and I probably should have made my pit a no-go area, so I'm not doubling back in it. Can't use the ground that's going to be excavated there. So we could have done that differently, but we can very quickly just say, okay, we don't want to use those. It is peace of mind, though, that we can actually access the top of our pit from this location. And then out of the remaining alignments that we're dealing with here, and well, that's the cheapest. So once again, we've got this solution. I'm going to hit save. And we're going to go over to location, and we're going to actually, again, flush out the geometry of the site and look at it in more detail. And rather than creating something new, let's continue working in that same file that we did our exploration road in. All right, so to add alignment, we're going to right click in the Project Explorer panel. I want to use a feature from a terrain file, so we'll run with that. We're going to use the currently selected terrain feature, and we're set. Now to kind of account for well, the additional information that we have, I'm going to just tell it that I don't want to see this other information, at least not right now. So we're only looking at our haul road. And then well, we've added that pit. So let's add in our pit as a reference surface. So that's a terrain file. We can add it in. And if we want to see our fills spilling down into that pit, we could add it in our merge topo surface. And then, okay, so we're kind of wrapping our head around about the project. One more thing here kind of as a background item, and that's the image. So if we want to see our image in the background, we certainly can throw that in too. And then, well, let's start flushing out our geometry. So I'm going to go a little slower than what we did in the exploration example. So when we get our Path Explorer solution, it's giving us a polyline that's cognizant of the curve constraints that we've given it. So if I want to turn that into a proper alignment with curves and tangents and not go through and trace everything and find individual curves manually, I'm going to use the polyline to alignment tool. And we'll let this go. Now it would just continue to narrow in on a better and better solution, but I'm going to just run with what it's found there. So we've got a series of curves and tangents. Next, I'm going to update my cross-section geometry. I'm going to go over here, and while I previously ran with this machine trail template for the exploration road, But here I want to have a road that's more fitting for actual haul usage. So with this, my resource low volume road template's probably pretty close. Now here I've got a road width of 4 meters, some surfacing being applied. Big thing that I want to account for here is I want to have a berm. So I could go onto the eLibrary and grab our haul road templates that are in version 11. But for the sake of showing something new, instead I'm going to merge something in. And I'm going to merge in a few templates that are going to be available in version 12. So we can see we've got a few to choose from. One's just this simple berm where, well, it would be fit. Another one we've got is a little more complex. So the berm's part of the road, and the berm's made out of our base material. And then here we'll go with something a little different too, where the berm is a separate material on the outside of our daylight. So I'm going to take this component and we're going to place it in here. And we're going to do the same to the left. Now, since that's our default template, I don't have to assign it, but if it was a case where I wanted to assign different templates to different station ranges, I could do that in the assign by range. But yeah, here we don't have to worry about it. Now for this, I'm going to just drop this down. So I'm on the to be bench, and I'm going to do that vertical optimization that I did previously with the exploration route. So with this, we're going to go in here. We're going to tell it, okay, we don't want to go with 15% grades. We're going to go with those 8% grades. We're going to go with a reduced K value, or I guess a larger K value, gentler vertical curves here. We can add in control points at the start of our alignment and at the end of our alignment. So we're at a particular elevation if we'd like to be. And software is going to look at our earthworks costs. If we had different subsurface information, we could have added that in where we've got different horizons with different costs associated with it. But in this case, I think we should be good. I'm going to hit process. We're going to let this thing run. And it's going to generate a vertical alignment that minimizes our earthworks. And again, it's going to think for a moment. So
Perhaps we can tackle one question while you were waiting for that to solve, Matt, which is, can we add berms to the benching feature, and this was inside of terrain, or can that only be done in location?
You could. You could do the buffer tool and manually add them in. But from a practical standpoint, if it's part of your linear infrastructure like a road or a ramp, it's going to be a lot easier to do it in location. Just where you have the flexibility to move things around with your center line. But yeah, technically you could, and that could get right into the whole site design side of things. But short answer is yes. And the other thing you could do that kind of goes hand in hand with that. So if it's just the berms and the pit itself that you wanted to, or sorry, the benches and the pit itself that you wanted to add that in, you could do that as just a back slope on the berms, but otherwise you could just select the outside edge of your benches, buffer them up to give the top a berm, buffer it over, and then buffer them down. It would be fairly painless. But yeah, and we've got a solution. So I'll just jump back into the project that we're running with here. So we've got a optimized alignment. Here we can see that I'm spilling over a little bit right as we're interfacing here. Now, if we wanted to, we could have added in a full bench constraint into our optimization, so we aren't allowing to fill down into the valley bottom. I'm not going to worry about that now because we are going to tackle it when we deal with our pit ramp. But if we were just going to do a quick review of what we have on the go. We can see we're adhering to all of our grade constraints, our curve constraints. We can see that we've got a project summary where we're dealing with 40,000 cubes of earthwork, cut and fill. And well, we could put together our documentation really quickly, or we could throw in a culvert. So I'm going to just throw in a culvert at this particular location. Add one in the culvert tab. And then we're going to throw together our documentation really quickly. So for our documentation, I'm going to go to the multi-plot editor, and we could build that out from various views. So we could go in here, plan view, etc. In this case, I'm going to do the bulk of the work by using something that's already set up. So I've got a book layout that I like to use. So I can see I've got pages inside chapters inside of a book. I've got my title chapter, then I've got my plan over profile chapter, and then I've got my cross-section chapter. And again, just to touch on something new that's coming for 12, well, if I wanted to add in a view for my 3D, we now add in multiple 3D views to the document. So in this particular case, let's just back up here. And well, if I wanted that to be what I'm using as my overview, maybe we'll zoom out a little bit more here. We could create a 3D viewpoint, we'll call it overview. And then in that multi-plot, we can add our subview, so 3D view. We could select which view we'd like. And in this case, where I've only got one, it's just one, but we could position it as we like. And I'm just going to shift that to the back. So there we are. We've got a haul road designed in just a few minutes. We've got our pit, and away we go. So just kind of a pause there on terms of our workflow. And we've optimized it. We've done the stuff that's outside of the pit itself. And now we are going to switch to do our ramp. So for our ramp, and I wouldn't typically do that with, say, Path Explorer, just because Path Explorer is going to look to minimize our earthworks. And when we're dealing with the ramp itself, it's not so much a problem of how do I minimize my earthworks to build this ramp. It's more how do I limit interfering with other things that are going to be going on with my pit as we develop it. So for this, I would come in here, and for example, if I want something that's going to match up with my benches in my pit, so maybe we're going to push the back wall back, and we want to maintain those benches. We could come in here to templates, and we could go on to the e-library. And I will just grab a slopes component. So we can see we've got a flat benches component here. So we could bring that in and we could configure it. And it's basically just a fillable form. Now I happen to, for the essence of time, I happen to have one that's going to largely use up. So I've just called this ramp, and we can see that it's including my benches. So very similar to what we have for the haul road, just the slopes, a different slope component. So for this, if I want to go down into my pit itself, where instead of just letting the software do its thing, I'm going to right click my plan view, and I'm going to extend that alignment back. So I'm manually choosing where it is. Right now, it's just showing it set up there on the topo surface, which, I mean, we're probably not going to do that. And here so we can see our grades. And here where I mentioned that I'm not going to get too worried about that fill slope being there, because as I design my ramp, I'm going to be cognizant of my transition coming out of there. So keeping below that 8% grade. Now I'm going to say I want to have that ramp up to station 3.3. So assign by range. 0.3. We're adding in that ramp. There we go. So we can see, and we can just move this around however we'd like to get the geometry we'd like. So I'd push that back into the slope. Probably gonna make an adjustment here. Make sure we're not going too far. Add in our curves. So again, instead of just telling the software to figure it out for us, we can say I want to add in a 50-meter radius curve here, a 50-meter radius curve here. And then if we wanted to have vertical curves, it would be much the same thing. We just use the vertical curves tab. So very similar to everything else in the software, except we're just choosing the alignment location by hand. And it is, well, smart, dynamic. We can see our mass hauls changing. We can see that, well, we're increasing our cut quite a bit. And if we look at what we're actually doing there, we can see that I've pushed it back into the back wall. So yeah, it's makes sense that we've increased our cut. And of course, we could go through, we could refine that. But for the sake of time, I'm just going to switch over and we can see one where we've got our proper curves being defined and that benching being feathered in where the grade of the road is, well, near 8%, but our benches are flat and matching the elevation of the pit. And it's kind of a weird one to see, but just with the orientation of things. But if we go that way, we can see that it's a little bit of a trick just with the, well, the curvature and the benching with that, but they are at the same elevation. So with that, that is both the haul road using Path Explorer and optimization, and then we've got the pit ramp, which is part of our haul road, which we've designed manually. How are we doing for time?
We are over time, but we did
course.
promise it. Let's do it anyways. Let me grab my screen here again. Okay. For fun, let's go slightly over time. We're going to tackle stockpile volume calculation. So again, first step is getting that survey data loaded in, building a terrain model. We've already got that. So here, Matt can simply go find the stockpile that's located in his wonderful project dataset, create a boundary feature, and then calculate volumes. It's probably the simplest of all the workflows we're going to show you today. And with that, we'll pass it to Matt, and then time depending, we might tackle a few of these questions. So yeah, Matt, it is coming back to you.
All right. So yeah, as yeah, totally the easiest thing out of all the stuff that we've been doing here. So I'm going to go right back to my topo file. So the same one that we've run Path Explorer in and whatnot. And this, where it happens to be in, well, looking at an additional pit for an existing mine site, there happens to be a stockpile already existing in our data set. So of course we could do stockpile calculations if we were lucky enough to have kind of pre-stockpile survey and a post-stockpile survey. We could do the calculations between the two surfaces, kind of like when I did the well, calculated the intersection feature when we were clipping our pit. But here where I've got that pile, if I just want to know how much volume is within that pile, well, I could draw a feature. Now I'm going to just call this stockpile. And for this, I'm going to make it a draped feature. And I'm going to tag it as a surface volume boundary. And all that's going to do is give us the feature that defines the extents for our calculation. So I'm just drawing around this feature. In this case, if I wanted to, I could have also just created a contour around there. But we'll draw it, modify, close. So tagged as surface volume boundary. We're going to go up to terrain modeling, calculate volumes, and instead of doing that calculation between two surfaces, we are going to do a volume enclosed by a single surface. we don't want the volume enclosed by our total surface, so we turn that checkbox on, which is going to highlight it based off of the features that would have that property assigned. And there we are. And of course, what's relative to what depends. So in this case, we have 9,000 cubes of fill in that stockpile, or it could be, if we consider it the other way around, if we were to cut that, well, it would be 9,000 cubes to cut. So we've got a stockpile in a matter of seconds. So I think that's it for me. If there's a few questions, we could certainly tackle them, unless we're
absolutely. Let's do a couple. There's a pretty long list here, and it'll help reduce how many follow-ups we have to do after the webinar. So the first question that we've got here, could you please confirm how super elevation is defined and controlled at horizontal curve locations, including the maximum values, transition lengths, or any other automatic calculation options? So let's go chat about super elevation.
All right, totally. So now for this example, I ran with our simple curves being applied, which, well, we're not really focused on super elevation. We could assign it manually if we wanted to, but it being a pretty low speed road with curves of 35 meters, I might not be worried about super here. But if it was a faster road, we could. So I'm going to do two things right off the bat. I'm going to just switch out of simple curves mode. And just so it's a little more pertinent, let's make a quick new alignment. And so if I were to assign a curve now that I don't have simple curves turned on, well, instead of just assigning a circular curve, I can also assign a spiral. If we went with a spiral, the transition length would be included there, but we'll assign a circular curve, and I'm going to say that it has a radius of 100 meters. So 100 meter radius, 50 kilometer per hour design speed for that particular curve. And it is populating a super of 6% here. And if we click the little plus here, well, we can see where that 6% is coming from. So we can come in here, and off the top, we can see that I've got a 50 kilometer hour design speed. So that's being defined. And then the size of curve that we're dealing with. So 100 meter curve, we've got that, 6% super being populated. So if we are defining our curves based off of a super elevation table, it's going to look at design speed, curve, and look up the value in there. With that as well, you could have a max super elevation that might even be less than what's in the table. And if you exceeded that, a warning would pop up. So if I exceeded that value in my table, say I had a 8%, it would say, well, I'm going outside of my super that I have associated with my, always wanted that to look up a value less than 6%. I could edit my table. The other way we can define our super elevations is based off of a friction factor, in which case that changes things a little bit. And the max super elevation value that's either assigned here or at the road class is going to be included in the calculation. So hopefully that makes sense for super. And let's just look at what we have here. So if we zoom in, we can see our road is being tipped to show that super elevation. So part of the question. The other part of the question is transitions. So again, well, what's being populated here? Transitions, widenings, runouts, etc. It's all going to be driven by tables. So these tables are user editable, same with that super elevation table. If we click open, we can see they're in the default directory and with a TBL extension, but basically they're text files that are tab separated. You can edit them, you can open them in Excel and edit them and save them out as a CSV. All these curve specs, if you hit save template, save them as your table, or save them with your TPL file, they're going to be included with that. And if you open a TPL file, it replaces everything in your file. If you merge, you can pick and choose what you bring in for cross sections. So kind of a verbose answer, but there's lots in there. It really is kind of super easy to use and smart. But yeah, it's all being populated based off tables. The tables are defaulted to, I believe, AASHTO standards, but you can customize what you'd like. And yeah, and then of course, instead of just winging the explanation too, if you want, you can hit F1, and the help files on all of the stuff are quite informative to explain how it works. So hopefully that answer makes sense.
Awesome. Okay, let's do another one, maybe two. So this question is, could you use the software for a tailings pond design?
Absolutely. Actually, I meant to have a tailings pond design just on hand. I didn't grab it. But conceptually, like an earthen dam, I guess you could do it two ways. If your tailings pond is more of like a bulk earthworks, like a true pond, you could do that in terrain, similar to what we did for our pits, but you could include berms and whatnot on it to, well, intercept flow. If it was more of like an earthen dam where you're maybe blocking a valley and filling that in, of course, there's lots of similarities between dam and road. So we could just basically set up our cross-section geometry to be appropriate, and we could choose that location as we'd like. And in that case, with an earthen dam, again, kind of like the ramp, your goal isn't really to minimize earthworks, it's to put the dam where you'd like to put the dam and know the earthworks involved. So tailings dam, yeah, I would use that manual workflow and click it in where you'd like. With that, you'll also see a kind of a cross-section template component specific for earthen dams with a different material for the core available later in 12.2.
Okay, I'm going to do one more, even though we're so horrendously over time. And this is one I think kind of ties nicely back to version 12, which is really the direction that we're heading in with the software right now, which is that your topo surface in your 3D view appears to be on top of your road/ramp. Can you clean that up?
Yeah. So yes, and with this, it's going to take a little bit to calculate. So I'm going to hold off on actually doing it, but if we pop this open, we have the option to include render merge cuts there, and then it'll, well, instead of having to use transparency, it'll cut things out. And just for context here, I won't do it because it is, yeah, it'll take a minute to calculate. But here, that pit is kind of tackled in a similar manner. So that's what it'll appear like, but for the road. So hopefully that answers the question.
Awesome. And with that, I do see a couple more questions left in the chat. Those ones a little bit more complicated for the seconds that I'd like to say we have left in the webinar. But I would like to thank everyone, first and foremost, for attending today. We hope that you got a good sense of how RoadEng can apply to several different typical mining applications, whether that is stockpiles, the haul road, an exploration access road, the pit design. If you are on support and interested in trying out a few of these new version 12 tools, please do reach out to us, support.team@softry.com, and you can absolutely get involved, get your hands on the beta version. We'd love to sign you up for that testing program. And beyond that, if you have any other industry applications, check out the other ones coming up, forestry, county engineering, and then renewables, all of which are going to feature little tastes of some of the excitement coming in version 12. Thank you, everyone. Thanks, Matt. And I guess that's it for the webinar. Only a casual 16 minutes overtime.
Thanks, everyone.
Thanks, sir. See ya.